Imagine an ancient ocean where a predator larger than a bus lurked beneath the waves, powerful enough to crush bones with a single bite. This was Megalodon, the biggest shark to ever exist, a true apex predator that once dominated the seas. But despite its unmatched strength, it vanished from the fossil record 2.6 million years ago. Why did this colossal hunter disappear? The answer lies in a tale of evolution, competition, and dramatic shifts in Earth's climate. Around 8 million years ago, a small baleen whale swam through the warm coastal waters of what is now Peru. Roughly the size of a modern beluga, this whale, known as Piscobalena, moved through the ocean, filtering mouthfuls of plankton-rich water, completely unaware that danger lurked below. Like today's great white sharks, a powerful predator stalked its prey from beneath or behind, taking advantage of any creature that lacked echolocation. Piscobalena was defenseless in this regard, making it the perfect target. The predator surged upward, striking with lethal force. And just like that, Piscobalena was no more. We know this dramatic hunt took place because the attacker left behind undeniable evidence, a fossilized tooth embedded in the whale's remains. The owner of that tooth? None other than Megalodon, the largest shark to have ever lived. At a staggering length of up to 18 meters, almost 3/4 the size of a blue whale, Megalodon dominated the ancient oceans. Its teeth, some larger than a human hand, were built for slicing through flesh with terrifying efficiency. Its jaws, wide enough to swallow a person whole. For over 10 million years, Megalodon was the ultimate apex predator, ruling seas from the Netherlands to New Zealand. Then, about 2.6 million years ago, it vanished, disappearing from the fossil record just as the Pliocene epoch gave way to the Pleistocene. No, it didn't secretly survive in the deep ocean, despite what Hollywood might have you believe, scientific. Evidence confirms its extinction. But why did the greatest shark in history suddenly meet its end? Megalodon was part of the lamniforms order, a diverse group of sharks that includes today's sand tigers, goblin sharks, threshers, and great whites. When first described in 1835, its massive serrated teeth led scientists to believe it was closely related to the great white shark. But as research progressed, experts determined it belonged to a now extinct family, the Otodontidae, or megatoothed sharks. One of Megalodon's earliest ancestors was Otodus obliquus, a relatively small shark from the early Eocene, about 20 million years before Megalodon appeared. Some researchers classify Megalodon as part of the Otodus genus, while others place it under Carcharocles. Regardless of its classification, Megalodon was the largest of its lineage, emerging in the fossil record around 23 million years ago. But how did it grow so large? The answer lies in the food chain. Megalodon's massive size evolved in response to the increasing size of its prey, marine mammals. The end of the Mesozoic era saw tectonic shifts that uplifted mountains, increasing nutrient-rich runoff into the oceans. This fueled the growth of plankton, leading to a boom in marine mammal populations, including whales, dolphins, and seals. With these high-fat, high-calorie meals becoming more abundant, predators adapted accordingly. Over 20 million years, both marine mammals and Megalodon's ancestors doubled in size, locked in an evolutionary arms race. Fossilized vertebrae of baby megalodons found in Panama suggest they were already 2 to 3 meters long at birth, half the size of an adult great white shark. Growth rings in their vertebrae, much like tree rings, reveal that these sharks grew rapidly, reaching their enormous adult size within about 25 years. For millions of years, Megalodon thrived. Fossils of its teeth have been found lodged in the bones of various whale species, including Piscobalena and even sea lion-sized pinnipeds. But around 2.6 million years ago, something changed, and the once dominant predator disappeared. Why? One leading theory involves climate change. The Pleistocene ushered in cooler global temperatures and extensive glaciation, also known as the Ice Ages. These shifts affected marine ecosystems, possibly making it harder for Megalodon to find food. Whales, a primary food source, started migrating to colder waters near the poles, potentially out of Megalodon's reach. However, in 2016, a study led by Dr. Catalina Pimiento tested the assumption that Megalodon couldn't tolerate cold waters. By reconstructing ancient ocean temperatures, her team found that Megalodon fossils existed in waters as cold as Fernster, suggesting the shark was more adaptable than previously thought. So, if cold waters weren't the problem, what was? Megalodon's extinction coincides with two major changes in the animal kingdom: the rise of new predators and a decline in whale populations. One formidable competitor was Leviathan melvillei, a massive 17-meter-long sperm whale named after Herman Melville, the author of Moby Dick. Unlike today's suction-feeding sperm whales, Leviathan had powerful jaws and enormous teeth designed to tear into flesh. It was a direct competitor with Megalodon for the same food sources. Adding to Megalodon's challenges, the great white, shark's earliest ancestor, Carcharodon hubeli, emerged in the Miocene, leaving bite marks in the same whale species Megalodon hunted. A few million years later, in the Pliocene, the modern great white, Carcharodon carcharias, appeared, smaller but faster and more adaptable than Megalodon. Meanwhile, whale populations were in flux. Around 3 million years ago, ocean circulation patterns changed when North and South America connected, affecting diatom diversity, the microscopic algae that fed krill, which in turn sustained whales. With fewer diatoms came fewer krill, leading to a decline in whale numbers from about 60 species to 40. This meant less food for Megalodon, forcing it into tougher competition with great whites and other rising predators. With a dwindling food supply and stiff competition, Megalodon, so perfectly evolved for a world of giant marine mammals, found itself struggling to survive. Ultimately, it didn't make the evolutionary cut, vanishing from the fossil record 2.6 million years ago. Its extinction reshaped marine life. Great white sharks and orcas took over as apex predators, but they lacked the sheer size to prey on the whales Megalodon once hunted. As a result, whale species began to grow larger, culminating in the emergence of the blue whale, the biggest animal to have ever lived, less than 2 million years ago. Megalodon's lineage took nearly 30 million years to reach its colossal size, a slow transformation driven by an expanding prey base. But today, whales are already enormous, with few natural predators. This leaves the niche of a supersized shark open once again. Could the great white shark evolve into the Megalodon of the future? Only time will tell, but one thing is certain: giant sharks may yet patrol our oceans once more. Thanks for diving into this prehistoric mystery. If you enjoyed this deep-sea adventure, don't forget to like, subscribe, and let us know what fascinating topics you'd love to explore next.